Hello, I'm going to show using CrossWorks for ARM to download and debug applications on the Freescale Vybrid device. So I've started up CrossWorks for ARM. Now I have to install the packages that are for the Vybrid device and the Tower board. So I use the package manager, which shows the list of available CPU and board support packages that we have, and now I select the Tower board, and that will also select the CPU support package that's relevant to it. Press next, and the packages are downloaded from the internet and installed. So I can now use Show Install Packages to select the board support package that I'm going to show an example from. The example is the dual core sample 5. So I'm clicking on that, and the project is loaded, and as you can see the windows change. So we have the project explorer that shows the Cortex A5 project and the Cortex M4 project. So the target board is connected to the USB port to the Kinetis OpenSDA, I believe it's called, and the Simsys DAP is a standard debugging protocol that runs on top of that connection. So I can connect to it by double clicking on the targets window. I can now press this button to download. So both of the processors are downloaded. On the Cortex A5 there's a simple project that flashes an LED when a button's pressed, and as you can see it's stopped on the Cortex A5 project. So I can let that go, and I can show the LED flashing. I can now switch context to the other processor, the Cortex M4, and this one is also stopped at the main entry point. I can now allow that to continue. As you can see, the LED is flashing. The Cortex A5 is still running. So I can set a breakpoint, and now it's stopped, and so the LED has stopped flashing, but the button press still works. The registers window here shows the Cortex M4 register set. If I flick back to the Cortex A5, then I can set a breakpoint on the button press, click the button, and now we've hit a breakpoint on the Cortex A5. So now both the Cortex A5 and the Cortex M4 are both stopped on breakpoints. As you can see, the Cortex A5 has the full ARM register set. The other option when we're set on a breakpoint is we can use the trace buffer to show the last set of instructions that were executed. So looking at the end of the trace buffer, this is the last instruction that was executed before the breakpoint was altered into, before the breakpoint occurred. And we can now go back through the execution trace of the Cortex A5. We can now let that one go, flip back to the Cortex M4, and we'll find a similar execution trace. But this one isn't quite so interesting because the program is spending most of its time just stuck in a delay loop. We can now remove the breakpoint, allow that to continue, go back to the Cortex A5, remove the breakpoint, and now, as we can see, the application is running normally. We can press stop debugging to complete the demonstration. Thank you for watching.